lesson IN4 or Indiana lesson 4 is on evaluating square roots, and this is on page IN19 in your little Indiana workbook. So on page IN19, Matt and his dad are building a treehouse. They buy enough flooring material to cover an area of 36 square feet. What are the possible dimensions of the floor if they only use lengths that are whole numbers? So area of 36 square feet. We're looking for possible dimensions if they only use lengths that are whole numbers. One thing, we're going to make an assumption here. They don't really tell us, but generally for a floor, for a room, something like that, normally we're talking about a rectangle. So we're going to assume they're doing this in a rectangular section. So if we're finding the area of a rectangle, the way we find the area of a rectangle is to multiply length times width. When it talks about possible dimensions, the dimensions here, it's referring to the length and the width. So it's saying what are some possible length-width combinations we could have if we only have whole numbers, and that we would come up with an area of 36 square feet. So there's different options that we have. We're just going to look at our different options. One option would be 18 feet by 2 feet. 18 times 2 is 36. Another option would be 9 feet by 4 feet, or 4 feet by 9 feet if you want. Another option would be 6 feet by 6 feet. Another option would be 12 feet by 3 feet. And one final option, 36 feet by 1 feet, or 1 foot by 36 feet. Now, if we're doing this, if we're building a treehouse, if you think realistically about it, the tiles on the floor in this room are each 1 foot by 1 foot. So if we went with the last option, that would be like having just one row of 36 tiles. So kind of like it's single file, and if one person has to leave, then if somebody's in front of you, they'll probably have to leave so you can even get around them. So some of these might make more sense, might be more reasonable. Also, if you think about it, if we look at the picture, not only are some of these maybe not really practical, there's another consideration. Kind of like if we look at this picture, you might notice around the sides, they've got this railing to make sure that we don't fall off. Okay, so there's a consideration with that as well. So the railing goes around the outside. So that has to do with the perimeter of our treehouse. So if we were building this, one thing is that the smaller perimeter is going to be an advantage for us, because smaller perimeter means less of this guardrail that we need to put up around. We have to buy that guardrail stuff, so if we have to buy not as much of it, then that means it's not going to cost as much for our treehouse. Also, practicality, it's going to end up that the smaller perimeter is probably going to be more practical space-wise, as far as getting around each other and stuff like that. So if you think about these, if this is 18 by 2, 18 by 2, 18 by 2, that's 40 feet for the perimeter. All the way around, 40 feet. 9, 4, 9 and 4, that's 26. 4 sixes is 24. 12, 3, and a 12 and a 3, that'd be 30. 36, 1, 36, 1. that's going to be 74. Okay, so we have all the way from 24 feet up to 74 feet for possible perimeters. If you can imagine the cost difference, you know, 74 feet, that's over 3 times as much of that that we would need to put around the sides there. So as far as less perimeter for putting up the guardrail, as well as practicality, the closer to a square you can get is the better. And in fact, we can get exactly a square here, 6 foot by 6 foot. So this goes also, you know, you might think, well, I'm not building a tree house, so it really doesn't mean anything. If you have a dog, you know, some kind of a pet that you've got like an outdoor enclosure, or you're thinking about doing something like that, or if you're putting up a garden and you're trying to keep deer and stuff out from it, getting into it, that would be another consideration. That'd be less fencing you have to buy the closer to a square it is, and it would still give you the same area inside of it. So example 1, Leah uses all the tiles in the box to create a square. Each tile is 1 inch long and 1 inch wide. What is the side length of the square? So you can see from the box here we've got 64 tiles. So basically what we're trying to do is use all 64 tiles to make a square. So what we can do involves square root, which we'll get to in a minute. Before we do that, let's just talk about a perfect square. So the number that is a square of an integer is called a perfect square. So for example, 1 squared, 1 times 1 is 1. So 1 is a perfect square. 2 squared, 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. So 9 is a perfect square. 4 squared, 4 times 4 is 16. So 16 is a perfect square. And you can see here on the pictures underneath as well, there's 1, 4, 9, and 16. And you can see there's that many, you know, individual smaller squares make up one perfect square, if that makes sense. Okay, so those are the perfect squares though, are the 1, the 4, the 9, and the 16. Our goal is finding something a little bit bigger. So we are trying to find for 64. So if you continue this, you might notice we are squaring numbers, multiplying numbers by themselves to get something. So 8 squared equals 64. So in other words, if we do an 8 by 8 square, we could use all 64 tiles. A similar but different way of looking at that is if we talk about square root. So square root, basically, just phrasing this a little bit differently than the book, when we find the square root, we're asking what number times itself equals this number. And there's a symbol there, kind of looks like a check mark type deal almost. That symbol means the square root of a number. So you can see in the example here what we're looking at is if we have the square root of 64, we're thinking what number times itself equals 64? And the answer would be 8. So you can go through this process like the book did. 8 times 8, and that's 8 squared. And then it's kind of like the square root and the squared can kind of cancel each other out. But otherwise, if we just go back to what we talked about here, what number times itself equals that number? So we know 8 times 8 equals 64. So the square root of 64 is equal to 8. And so our side length is 8 inches on that square. So if we look at the try it, Leah's friend Ravi has an additional 57 tiles. Additional 57 tiles. The two friends use all the tiles to make a larger square. What is the side length of the larger square? So we had before 64 tiles, and now we're getting an additional 57 tiles. So if we add these together, that's going to tell us how many tiles we have all together, which is 121. And so similar to the previous example, we had 64 tiles. We took the square root of 64 to figure out what our side length could be. In this case, we could take the square root of 121. In other words, we could try to think of what number times itself equals 121. This is maybe a stretch back to your days of learning your multiplication facts. So that would be 11, and so that means the side length is 11 inches. In other words, if we went 11 inches this way, 11 inches the other way, we made a square that would have 121 of these tiles in it. So example 2, they are just straight up giving us some problems to work out. So on A, we have the square root of 169. Generally, what I hear is that you guys are still just going up to 12 times 12, which is 144. This is a little bit bigger than that. If it's a little bit bigger than that, you can guess numbers. If we don't have a calculator even, we can just guess numbers until we figure out what it's going to be. Rather than just strictly guessing, you might notice an observation is that if something ends in 1, if they both end in 1, 1 times 1 is 1. So anything that ends in 1, possibly the number could end in 1. Like 1 or 11. 11 is 121, and so on. Anything that ends in 1, the square of that number is going to end in 1. Anything that ends in 2, 2 times 2 is 4. So any number that ends in 2, the square is going to end in 4. Like 12 times 12 is 144. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. So rather than just guessing, I can look at this information and see what ends in a 9. 3 squared and 7 squared. So if I'm figuring this out, square root of 169, I'm going to be thinking about something like, well, I know 12's not enough and it doesn't end in a 3 or a 7. It's pretty close though, so I might think to try 13. And if I try 13, if I multiply that out, I will get 169. If that didn't work, I would try 17. Okay? To get a ballpark idea, also you can figure out what tens it's between. 10 times 10 is 100. 20 times 20 is 400. So 169 is in between those two. The only way this can work and this be a whole number answer is if it's either 13 or 17. Okay? Part B is square root of 100. You might remember that is 10. 10 times 10 is 100. C, square root of 49 is 7 because 7 times 7 is 49. And D, square root of 16 is 4 because 4 times 4 is 16. So they kind of started off with the hardest problem there, really, and worked their way down. Is kind of what happened. So if we look at the try it part A, we're looking for the square root of 36. So square root of 36 is 6 because 6 times 6 equals 36. Part B, we've got the square root of 25. That would be 5 because 5 times 5 equals 25. Part C, square root of 81. So that would be 9 because 9 times 9 equals 81. And part D, square root of 1, is 1 because 1 times 1 equals 1. So if we look at example 3, Sean cuts one sheet of colorful poster paper to cover the bulletin board exactly. And I'm glad they told us it was colorful poster paper. What are the dimensions of the poster paper? So you can see this is 144 square inches is our area. Since it's a square, we can find the square root to figure out what one of the side lengths would be. So square root of 144, and if you figure this out, I'm okay with you guys just going straight to the answer. Square root of 144 is 12, and so this would be a 12-inch by 12-inch sheet of poster paper. So if we look at the try it, Emily wants to buy a tablecloth to cover a square card table. She knows the tabletop has an area of 9 square feet. What are the minimum dimensions of the tablecloth Emily needs? Okay, so this is ignoring the fact that tablecloths usually drape over the sides. This would be like just a tablecloth just covering strictly the top of the table, which I guess would work. So over to the side here, they've given us a sizable hint in that they're saying square root of 9. And again, if you want to cut right to the chase here, square root of 9 is 3 because 3 times 3 is 9. This would be a 3 and a 3 and a 3. They'd all be 3s if you're keeping track there. And by the way, then this would be 3 feet by 3 feet. So every single box there would be a 3 on that problem. So key concept just kind of recaps. Square root of a number is a number whose square is equal to that number. Or like I said, you can think of what number times itself would give us that number. So on the do you understand number 3, a square quilt has an area of 16 square feet. I'm not sure I've seen a square quilt before, but Bethany says each side of the quilt measures 8 feet because 8 times 2 equals 16. Is Bethany correct? And explain. So actually, since this is a square quilt, we would want to find the square root of 16. Square root of 16 is 4 feet. So this would be a 4 foot by 4 foot quilt. Okay, technically 8 feet by 2 feet, that would still give us an area of 16, but it's not going to be a square because the length and the width aren't the same. 2 foot wide isn't very wide of a quilt either. Might not be very practical for us to use. If we look at number 5, below is a model of the infield of a baseball stadium. How long is each side of the infield? So for this one, we could do the square root of 81, which is 9. So each side would be 9 inches.